All right, guys, one more video. There's a lot going on in this video, so I really want you to, every time I put a problem up, I want you to try. So when you see a problem, I want you to pause it, I want you to try it, and then I want you to watch me and try to see where you are going either on the right path or the wrong path, and kind of compare your work and my work. Okay, so you can title this in your math notebook, Practice Problems. Okay, so we're going to cover a whole bunch of things, but I really think it's going to be more beneficial if you try every problem that I give you. So, first problem, please try this one. Okay, and you are not using calculators on this, okay? So don't even do it. I want to see all your work when you show me these problems. Please do not use a calculator. Okay, so go ahead and pause. All right, let's talk about how to do this problem. Now, I wrote this problem like this, but this is not at all how I want to solve this problem. Okay, so what I want to do is I want to, and this is how I do it. This is just a strategy for this first part. I want to come up with the sign first, so that once I really get into the numbers, I'm not stressed out about the sign. So we've learned our signs, we've done our sign charts. We know a negative times a negative is a positive. So I'm going to write that. So now when I go work with my numbers, I don't have to think about signs. So 1.25 times 3. Okay, so when we add numbers, we need to line up the decimals. Or when we subtract numbers, we need to line up the decimals. But when we multiply, we line up to the right, and then at the end, we're going to count in the decimals. Okay, so I know some of this is review, but we forget this stuff, okay? So 3 times 5 is 15. 3 times 2 is 6. With that 1 is 7. 3 times 1 is 3. There was 1, 2 decimals, so 1, 2 is my answer. And then we know it was a positive 3.75. And we want to ask ourselves, is this a reasonable answer? Would 1 and some change, that's how people say it, like 1 and some change, times 3 be 3 something? Yeah, that makes sense. 1 times 3 would be 3. And if you look, this would be like a quarter, and 3/4 is 75 cents. Okay, so we want to make sure that we don't get so caught up in the math steps that we get an answer that doesn't make sense. Okay, so we want to see the reasonableness. I really like the strategy of coming up with your sign before you even start with your numbers. Just like I said, it's a strategy. Okay, next problem, please try. Negative 2/3 times negative 1/2. Oh yes, there's the third one, times negative 3/5. Now, I'm going to kind of tell you how to do the problem before you start, and then pause me. So we're really multiplying 3 fractions. It's the same strategy. Multiply all the way across and then reduce. You can use some cross-canceling. You can technically kind of cancel anything top and bottom. So like maybe the 3's. And then the other thing that you need to know is a negative times a negative is a positive, but then times another negative is back to negative. So it's kind of that every other pattern. If you have 3 negatives, it's negative. A 4th one, it's positive. A 5th one, it's negative. A 6th one, it's positive. So our even numbers, if they're all negative, end up positive, and our odd numbers end up negative. So if you need to take 2 signs, put them together, negative times negative is positive, and then bring that last sign, positive times negative, is back to negative. Okay, so now you pause me and try the problem. All right, hopefully you attempted it. So there are 3 negatives. It's an odd number, so we know our answer is negative. So let's write that so we don't forget. Now I'm just going to go kind of old school and just do 2 times 1 times 3 would be 6. 3 times 2 is 6 times 5 would be 30. And when I reduce this, I'm going to divide them both by 6. So I'd have 1 over 5, and I decided my answer is negative. Now I'm going to put it in the top because that's how we've been practicing. but you may see in the book, it's going to put it kind of like right in the front. Like I said, just don't put it twice and you will be fine. Hopefully you got the answer right. All right, let's try another one. Okay, this one is 5 times negative 2/3. Go ahead and try that. To try it, make it 5/1. That's your strategy there. Okay, so pause me. All right, let's try it. So I want to rewrite this as 5/1 times negative 2/3. Now, a positive times a negative is a negative, so I know my answer is negative. 5 times 2 is 10. 1 times 3 is 3. I can't reduce it, and I can't forget my negative. All right, hopefully you got that one correct. Let's try another one. Remember, you have to try these. Even if you're getting them wrong, it's okay, because when you take your work and you compare it with mine, you can see where you were going wrong. And there might be things that you kind of thought were true, and now you're seeing that they're not, and that is a really good lesson. Maybe you're just getting them all right, and that's awesome also. All right, let's throw a decimal at you. So negative 1.8 times 5. Go ahead and pause. All right. So like I was saying before, negative times positive is negative, and then I want to just line up to the right, and I'll count my decimal in because there's only one. So 5 times 8 is 40. 5 times 1. So not, and then I move my decimal in, so 9.0. So negative 9 is my answer. Okay, and think of kind of, is this reasonable? 1 times 5 would be 5, and 0.8 is really close to 1, which would be a whole nother 5. 10's really close to 9. I'll say it again. 1 times 5 is 5, and 0.8 is really close to 1, and 1 times 5 again would be another 5. 5 plus 5 would be 10, and 9 is really close. Okay, so I just kind of want to make sure that my answer makes sense. All right, we have, let me see, 1, 2, 3 more that I want you and I to try. So please try 203 divided by 15 without a calculator. All right, pause me. All right. I'm going to erase the problem right now because I want to put it in a format I can actually use. So remember, the first number goes under, 203 divided by 15. Okay, so 15 goes into, doesn't go into 2, so I don't start here. I start here because it goes into 20 one time. 15 times 1 is 15. Remainder of, so now I subtract a 5, and then I bring down my 3. So 15 into 53. Now I'm not sure, so I'm going to go 15 times, let's try 4. So 0, 2, 4, 5, 6. Oh, too big. Too big. Go back. So try 15 times 3. So 15, 3, 45. Yep, that's as close as I'm getting. So I'm going to put a 3, 45, and then I'm going to subtract. Now, at this point, I see I'm moving on past the decimal, so I really like to put my decimal up here so I don't forget. Okay? So I'm going to subtract 5, 6, 7, 8, 9, 10, 13, 8. I put a 0 and I bring that down. Okay, so maybe 15 times, let's try 6. Nope, that's going to be too big. Let's try 15 times 5. So 5, 2, 5, 6, 7. 75. If I go, yep, so 13.5, 75. I end up with subtract a 5, bring down a 0. So back to my 3. And because remember over here, 15 times 3 was 45, so I'm really close to this. So now 45, and I end up with another 5. And so we see this pattern, and we can go ahead and underline that. And then what I like to do sometimes, just because I know right now that you're probably practicing long division because we haven't done it in a while. So let's pick up a calculator and just check ourselves and look. really all we were doing was repeating the 3, not the 5, 3. Okay, so watch. Right here, if I would have kept going, I would have realized it's just the 3 repeating. So sometimes that's a good lesson that don't stop your problem too early and make assumptions. Okay? I also am going to go ahead and use an excuse that I ran out of room. But you can't use that excuse because you have paper, not this little whiteboard. Okay? But really good lesson that when you see a repeating pattern, make sure you know it's the right pattern and you don't just make assumptions. Okay? So hopefully that kind of reminds you, long division. I really want you for the next couple weeks, at least until our common assessment's done, I want you to be practicing all of your math without a calculator. I know it's going to take you longer, but when you hit that common assessment, I promise you you're going to do so much better if you feel really confident with this. Okay? All right, let's do, I think I have 2 more problems. So go ahead and do this one. Okay, so go ahead and pause. All right. So again, I'm going to erase this and put it in a format I can use. 4.1 divided by 2. So 2 goes into 4 2 times. I know I need a decimal. So 4, 0, bring down a 1, 0, 0. I bring down a 1 because I subtracted. And I have another 0. And 2 goes into 10 5 times, and it goes in evenly, so I know that I am done. Okay, so I picked this one because I want you to remember what to do with that decimal. And then ask yourself, is your answer reasonable? Would 2 times 2 give you 4? Yes. And would 2 times 0.05 give you 0.10? Yeah. Okay, so we feel good about our answer. Let's do one more together, and there's a really specific reason I picked this one. So 6 divided by 1.2. Okay, so pause and see if you can remember how to do this one. All right, I'm going to rewrite it in a format I can use, so 6 divided by 1.2. Now, I know you forgot how to do this. Well, maybe not everyone, but I bet you forgot how to do this because I teach 8th grade sometimes, and my 8th graders are always like, uh-oh, what do? I forget. So that's why I picked this one, so that when you get to 8th grade, you don't make that same mistake. What we need to do is we need to move this decimal and really work with the 12. I don't want to work with the 1.2. So if we move that decimal, we give ourselves a decimal here and we move it also. So we're really putting 12 into 60. Okay? And we know that 12 times 5 is 60. This ended up being easier than I thought. But the point of the problem is I really want to remind you to move that decimal. Okay, so keep practicing. This will all come back to you pretty quickly, and I will see you soon.